Hello and welcome to the OCP Virtual Global Summit. Today we're going to tackle the subject of can block storage devices converge on NVMe? My name is Mohammed El-Batal. I'm a technologist at Seagate. I'm part of the CTO office and I lead future technologies for the Cloud Systems group at Seagate. Quick legal disclaimer and we're going to move forward. Just an overall view of today's ecosystem of HDDs. We have a lot of different SKUs that are existing today, maybe 2 or 3 or 4 even in some cases. I'm listing 3 of them here between enterprise and hyperscale, as well as in the future as we look at multi-actuator and dual actuator, as we look at 24 gig SAS introduction, and we look at the split in single port versus dual port affecting also things in different SKUs, etc. So we have a lot of SKUs, and we're putting a stab here at the NVMe HDD as a single actuator device. You could have dual actuator as well in the future. And as we look at the future, we view this as an enablement of SKUs that are going to solve different problems. And the NVMe HDD SKU that we're looking at to consolidate the various SKUs potentially could be a very viable option way in the future. Things don't change overnight. We all know it takes 5 to 10 years for interfaces to change on disk drives. Things move slow because it's a large adoption strategy. Data centers pay a lot of cost to create the right infrastructure for the right drives. As we look at this, not only from the vendor perspective and the consumer perspective, but also from a technology enablement perspective, we view NVMe HDDs as strong enablement to the composability infrastructure because they can play in the same NVMe or Fabric's composable infrastructure. That said, it really is a combination of data path, firmware, silicon investment that has to be optimized for that. And the ability to optimize all the solutions around standards is what we're looking for here, not having custom solutions. The hope is that we can use a standard NVMe driver and map it into that, and that's what we're going to talk about the TPAR that Seagate is sponsoring there later. Initially, NVMe HDD will target specifically transitioning the SATA nearline HDDs from a cost point. So we're going for the low cost first, and then we're looking to follow with additional features to replace SAS slots with NVMe dual port capabilities, etc., etc. But we know this will take time, and the transitions always will take time, as we said. Unified data at rest and data in flight security is critical for everyone. It is important to think about NVMe HDDs as a unifier with SSDs and the Fabric ecosystem around the same security solutions and the security processes. And from a standards perspective, the ability to use the same standard and the same keying capabilities across both, that'd be great. Optimize device management with NVMe MI and avoiding to have, various proliferation of different standards in that area. As we go into a redfish, swordfish infrastructure for managing the composability as well as the CSI for orchestration and creating compatibility with the rest of the container and VM-based orchestration software applications. We look at also on the back end of the solution to standardize around NVMe MI to simplify the investments behind these high-density solutions for HDDs in the data center. Standard NVMe protocol delineation, i.e., from a performance perspective, timeouts, QoS, power, media types. So, spinning media could be another type versus flash versus source flash memory within the NVMe or Fabric and the NVMe standard driver. And then, there are some key aspects of having a PCIe connection to an HDD that has NVMe capabilities is you can actually tie it into an infrastructure of accelerated solutions, just like we're tying SSDs into those infrastructures. So FPGAs, GPUs, CPUs, etc., that have accelerations and like data reduction or active drive solutions can now enjoy the same NVMe interface, PCIe NVMe NVMe interface to directly connect and not having to have upper level SCSI layer above that. It will be 13 commands that can be implemented in hardware on the target side as well as initiator side, and you can actually talk to these guys with hardware accelerated solutions to accomplish these tasks. Also, dual actuator drives are needed to maintain the IOPS per terabyte curve, and we view the bandwidth with those dual actuator and multi-actuator drives increasing beyond SATA's capability. So it is a pleasant alternative to SATA in terms of connecting into a PCH, for example, or directly into a CPU infrastructure, x86 CPU infrastructure. Last year, my colleague John Trantham presented on the various options that we visited and looked at in terms of connectorization for an NVMe HDD slot, and came down to U.3 as the best and the most balanced option with SFF 8639 connector, possibly with reduced pins to reduce cost. So these are John's slides from last year. I'm going to just keep them in this presentation so remind people what the differences are between the U.2, U.3, and the SAS, and how the a dual two-lane device, either 1x1, 1x2, or 2x1 capable device can live within that infrastructure on U.3. And this is the proposal of a pinout where using the opposite side of the connector for one port, as well as the port 0, port 1 on each side of the connector. We also looked at signal integrity from a channel model on comparing PCIe Gen 3 specifically to SAS 3. As you design large, high-density enclosures for housing these HDDs, typically we request about 19 inches of trace to support those solutions, and that's why we're thinking Gen 3 is more balanced in its capability to produce 19 inches of trace with around 10 to the minus 15 bit error rate. These are the hardware aspects of the NVMe HDD in our proposal. So lane count for SSD is 1x4 versus HDD is 1x1 or 1x2 for the single port. As well as for dual port, it will be 2x1 for the HDD. U.3 connector with reduced pins. Reduced pins on the receptacle on the target device versus the receptacle on the backplane could be a standard U.3 connector that can support both SAS drives or SATA drives or these new NVMe HDDs. And ideally, we would support Gen 4 as well, but in here we're saying Gen 3 is sufficient for the bandwidth. But this slide is indicating that Gen 4 can be ported on the SSD and the HDD in the same silicon, honestly. But we're saying Gen 3 would be sufficient for the drive solution. Spread spectrum clocking with SRAS as well as ref clock support on both, SM bus support on HDD. We're still TBD on the unpowered VPD support, so we need your help in making a decision on that. Reset pin is the same TBD at this point. SFF 39 for the connector, 12 volt only, and EMF for PFAIL support. And EMF is electromotive force, so leveraging the electromotive force of the spinning media to offload the DRAM content of the cache into flash, and we've had that feature for a few years, and it'll be enabled on this NVMe HDD as well as part of PFAIL support. The biggest controversy we had internally as we discussed about this was spin-up, and I expect that to be discussed heavily in the TPAR as well in the committee. The proposal that we came down to is that after power on reset, defer spin-up until the first controller is enabled. After that, use existing NVMe power management features to control spin-up. So basically, the power management features can support transition to and from non-operational power states to support spin-up or spin-down. We want to protect from having the system just power up and all the drives spin up at the same time and crowbar and power supply. So the best way we can think about it is the drive will stay offline or unspun until the power management commands come in. The autonomous power transition will be disabled, basically. The NVMe HDD features from a software perspective, from a protocol support perspective, were advocating support of CMD. It's critical to support the lowest and most optimal transition to NVMe over fabrics by placing the fabric buffers and queues on the drives with a reasonable amount of memory on the drive that we can allow. PMR, we don't feel it's needed, but we kept it TBD to see what the feedback is. SGL support is a yes. NVMe MI in-band is a definite yes, because that really is a consolidation of enclosure management capabilities or device management capabilities. And then SM bus support with NVMe MI out of band is yes. ZNS support, because it could translate into SMR enablement. And power management, yes. Self-test, again, is a yes, and we'll leverage that across both HDDs and SSDs with the same enclosure management, routines, etc. Sanitize command for fast erase, yes. Telemetry is a yes, and that's a critical thing to unify between SSDs and HDDs as well. PFIL support, as we said, yes, with the electromotive force of the drive, which is, it's a simpler solution than supercaps, and we don't need a lot of cache memory for offload. Endurance groups all the way to ANA, we believe those are not critical for HDDs, and those are points of argument that we're here to. I should have put them actually TBD, but at least I'm showing our position on it is a no at this point. So final call to action is Seagate is in the process of doing the TPAR, the NVMe committee for the NVMe HDD supported in the same driver. And then Seagate is open for collaboration with other HDD vendors to lead this solution and see who gets it to market first. Additional OCP member suggestions or contributions are very much welcome. So this is a stab at it, and we're putting it out there for people to make it better, hopefully, with adding to the ideas. And we're basically responding to customer demand. We're not really pushing it as a vendor. We're providing it because of a market pull. So obviously the market is asking us to look into that, and that's why we did it. Depending on the specific POC schedules that are needed are, at least within Seagate, we believe that we're capable of producing a CTU unit within 1 or 2 years, on the early side, and then go to production in 2 to 3 years as the market is ready. That could be accelerated if there's enough market pull as well. And let us know if NVMe HDDs would be useful to the OCP community, why and when, and if we're missing anything, please mention it, provide us notes, provide us feedback, and we'll be happy to address those points in the committee. Thank you very much, and please stay healthy and safe in these difficult times. Have a great day.